Okay, so I'm going to do something a bit controversial because I'm going to try and do a presentation without slides. I'm just going to talk to you for a bit, and then I'm going to show you some code as best I can. And so I'm going to talk high level, and so you're going to have a job to do rather than just sitting there and going, oh, that's all very interesting, and falling asleep. If something doesn't make sense or you'd like more detail on something, you're going to have to put your hand up and ask, and I will go into more detail. Otherwise, I'm going to assume this is all obvious to you. I'm going to plow on. So, in talk theory, talks have three things, and that's what a good talk is. So what are my three things? I want to explain a little bit what I mean by data wrangling and awkward-sized data, and I want to persuade you that to do it, you need a general-purpose programming language. And the third thing I want to do is persuade you that that language that you should use is Clojure. So what do I mean by data wrangling and awkward-sized data? So if I take an example of all the Guardian's content that's ever published digitally, that is about 100 gig of data, which is too big, right? Because awkward-sized data is kind of Goldilocks data. It's not too big and it's not too small. So 100 gig, I couldn't get this on this laptop. This laptop has about 8 gig of RAM because I'm a Scala developer, but when I switch off IntelliJ and I'm not compiling Scala, I've got like 4 gigs to use. It's massive, right? I can get anything 2 to 4 gig size into memory, and it's like a really fast database right here. So the metadata of the Guardian's content is much less than 100 gigs. Most of that is the writing and the pictures and all the video and the content. So the metadata, I can force that onto this laptop. So it's kind of Goldilocks data. It's the thing that makes it awkward is that it's not in its final form, right? It requires some munging, some shaping. It's not a perfect table. There are missing bits of information, and you need to kind of do some operations on it before. If you've got something that is a perfect table with an even amount of columns for every row, you don't want to be using this. You want to put that into a relational database and use relational algebra because there's years of that. It's amazing stuff. You should just do that. So also, I want to say that spreadsheets are amazing, right? Like half this world runs on spreadsheets. And if your data is about 10,000 irregular shaped rows, then spreadsheets will do amazing things for you. As long as you can look at the data on the spreadsheet and see most of the data in one glance, then you might as well use a spreadsheet. So you've got to have a problem that is slightly bigger than I want to take this column and add 20 to it. So there has to be some complexity or interest to it. So that's the kind of thing that I'm talking about. And I think as soon as you want to do anything with that awkward data, then you need a general purpose language. And I've got one reason which I think just seals the argument for me personally, and that's I/O, right? As soon as you want to read something and write it somewhere else, that is a massive problem for every database vendor, and indeed for most DSLs. So if you want to take a row from Postgres and write it to Mongo, which is not an unreasonable thing to do, right? If you have two systems, you may want to do that. Then Postgres is like, no way, man. The only thing I allow you to do is create a table. And Mongo's like, why would you ever want to do that? You can do everything in Mongo. And so even the vendors are expecting you to wrap them together in some way. And DSLs take their power from being inherently limited, right? As soon as you add something like file handling, which is really complicated, right? Because if I'm talking to a web service, that's actually a really complex set of logic. There's a reason why you can't select from HTTP whatever. Because what happens if that service returns a temporary overloaded status code? Well, quite reasonably, you might want to retry a few times and see if you can pull that data down. But that's really difficult to express in a query language. So you need to hold some sense of state, like what was I trying to do, what am I trying to do next? And as soon as you put that into a DSL, it just becomes a general purpose language. For me, that's just enough, right? Being able to read and write things means you need a programming language. As soon as you do I/O, you're going to need all the features of a programming language. But in addition, things that you might reasonably want to do is iterate over your results, change them, and then use them in another query, right? So you might want to combine some data operations. And that's also surprisingly difficult in most of the DSLs that are generated for manipulating data. You know, if you want to, if I take SQL, which is kind of the one that probably people are most familiar with, is that you can take a select statement and you can have a where clause, which is itself taking things from a select statement. But if you want to kind of do anything that's conditional, right, so if I'm not strictly a projection, given the set of IDs, use that in the next projection. If I want to say take every ID that's less than 100,000, that's really difficult to express in projection queries. So if you want to iterate over data, if you want to write it, if you want to express generality, you know, like in your spreadsheet, the most common error is like, that's why I think you need to be able to see it at a glance, is if you when you're pulling down the column to do your formula and you miss the two bottom rows because you didn't quite pull it down far enough, that can be massive consequences on your calculation, right? And it's the biggest reason why we don't have visual programming languages, because you want to express things as an abstraction over the data. If you want to do all that stuff, a DSL is not going to do it. There's no data product that is a metadata product that sensibly combines things together. So I think you need a general programming language. And my opinion is that you should use Clojure as that language. And a lot of the reasons come from Clojure being from the Lisp family, right? So Lisp is a list processor, right? So there's a clue in the name. It's a list. And every function call, the very basis of Lisp is data structures. There's this kind of, it's kind of almost like a tired cliche, right? Which you will have heard is like, code is data, data is code. And you go, oh, what does that really mean? And what it means is that the very essence of Lisp is a function call. If you want to invoke a function, then the structure that is a function is actually a list. So in the first position, you have the identity of the function you want to invoke, and all the other positions are just parameters that go into that function. So the list, the data structure, is fundamental to the language. And there's a lot of stuff that just kind of progresses out of that data being first order to the language that Clojure picks up just due to its lineage and inheritance. You know, there's also things, so I just heard in the last talk about like Java's getting a REPL. It's really exciting. And REPL is one of these words that kind of like refactoring. It's like things that people throw around. It doesn't really mean what they think it means. So a lot of languages have shells, which are great. You know, you can interact with your code. But what Lisp has is a genuine read-evaluate stage, right? So you can pull data in natively, manipulate it with the same functions that you would any piece of code. There's no parsing point, so the evaluation turns it into first-order situations. And once you've had this kind of dynamic, rich interaction environment where you can change the code as you go along, so it has the same property as spreadsheets. You know, you can redefine key values and generate new projections based on new initial states. It's really hard to go back. It has all the good things about the SQL query language, where, you know, where you can run a query, go, oh, that's not quite right. I'm going to add a column here, and I'm going to add a condition here. It has all those same things that is good about DSLs and interaction with data, but a higher level and a greater level of power. There are also some things that are unique to Clojure. You know, there's a reason why I'm not saying, oh, you could just use Common Lisp for this. It has great immutable data structures, which if you're data wrangling is really useful, right? Because you have some source data that you've created, and you're always generating projections. You're never changing the underlying data. So if you make a mistake, instead of completely destroying your input, you go, like, oh, fuck, the projection was wrong. And you can just try again and iterate over it. It's lazy by default, which is actually really surprisingly difficult to find in programming languages. Clojure is the only one that I'm really aware of. In things like Scala and Python, you have laziness, but you're entirely responsible for it. You construct it yourself. And why is that important? Because when you're dealing with these reasonably sized, these awkward sized data sets, you don't want to realize full copies of the data. One reason that I find Scala quite frustrating is that it's really easy to turn a sequence into a fully realized memory structure. So you've got, like a gig of data, which is absolutely fine. You're processing over that. And suddenly, somewhere in the Scala code, it suddenly goes like, oh yeah, you've done a map, and Java's even worse for this. In Java 8, it's like random, which, well, it's not random, there's probably some design, but some of those sequence methods are lazy, and some are not. So it's like, oh fine, this fits in memory. No, sorry, I've got to realize the whole thing, so I've got to create another gig of data structure where I look through your entire array and see your transformation and then figure out whether you can do this or not. And what happens mostly is that you didn't assign enough memory and you blow up. It's really frustrating. So laziness is important because if you have a great immutable structure and a sequence over that, you're using a tiny amount of data, memory, to do all this processing to generate just what you need without affecting the input. Yeah. Fine, that's enough for me. Those are good reasons, I think. So that's pretty much all the talking I want to do. So can I ask, who amongst you kind of feel like you have this problem where you need to take some data, you need to change it and transform it, or you need to answer queries from colleagues? Okay. I think probably most people have this problem. Most people turn up and go, can you tell me how many of things are like this? And I'll come to a few examples. And how many people use Clojure or are interested in using Clojure for doing that? Okay. Of the people who didn't put your hand up, is there anything I can tell you right now that would change your mind? Or are you just not interested in this at all? Yes. Yeah. So I didn't want to, this is great that you've asked it because now I have an excuse because I was going like, oh yeah, Clojure has an amazing set of, community contributed libraries around stats and, interfaces to databases and processing data. And I would say that, right, because I'm advocating it. But it is kind of true. It has things around parallel processing. It basically uses the Java drivers for all the native databases and just is putting a native wrapper around them. So you have all the things that you have in the JVM, plus the Lisp and the Clojure aspect on top of it. And yeah, it's great. Talking about Python, I do have an example. I was going to leave it till later, but yeah. So we are in the middle of doing a migration from all our content used to be in HTTP because we're a public website, right? So all our resources need to be on the internet and cacheable, and we would never use HTTPS because you need to encrypt it, and that's expensive, and it really slows it down. It's not cacheable, all those things. Well, all those problems have been fixed now. And Google gives you a search boost if you're on HTTPS, and everyone's worried about man-in-the-middle attacks and injection. And so I need to go through the data and say, okay, which of our old resources are on HTTP, and do they already have a HTTPS representation? So in this case, it's looking at JavaScript. And it's saying, okay, if I find a HTTP representation, can I find the HTTPS? So it's a really simple thing. I've pulled some data. In this case, I've run the query. Well, so here's my first regret about using Python. I probably could have fixed this, but it would be much easier to connect to the database and pull the live data down. So Python has decent Mongo support. I didn't. I ran Mongo and I teed it in the shell, and then piped that to a file. In retrospect, it worked, but it's stupid. Would have been much better to have a connection to the database. And then, so this Python code is doing all the things you'd expect. It's going like, just replace HTTP with HTTPS and see if you've got 200. Now, I ran the script, and the thing you've got to remember is that this line wasn't here. So I ran the script, takes a couple of minutes, checks for HTTPS, and generates the list of items that don't have HTTPS. And as soon as it stopped running, I had buyer's regret. And I went, oh, shit, no, I've got a new question now. Right? I now want to know whether the HTTP, this line here, the first line, whether the HTTP version existed, because it turned out we have loads of duff links in our content that are 404ing. So those things need to be corrected before I check for the HTTPS version. And if I'd been running it in the REPL, I would have gone, oh, that's stupid. Well, I would have the list of data that it just generated for me, and I could have written the functions, just go like, now tell me which one of these is 404. But I'd written a script because it would be simple, and I'd run it once, and the script quite reasonably had stopped executing it, had thrown away my context, and I would have to rewrite a new script and rerun it. So in a Python shell, because it is a dynamic language, you do get some of the things. You can reload modules and you can reset things, but all that support has been added on kind of after the event, whereas in the REPL it's like first order. It's really easy to get a data set and then write another quick function in the REPL to use it, and then take that function and put it into your source file. So other languages are obviously available. They have some features, but in this case, it's one where I regretted doing it in Python. And I like Python a lot. There's a very long answer to your question. Have I changed your mind? You are a tough customer. Anyone else for any more? Because this is more fun than me telling you things.
So for me, I have curiosity about data, but not much knowledge. I like to see examples.
Okay, I will show you some examples in a second.
I was excited by what you said about Clojure being loaded by default.
Yeah.
Do you want to demo this, explain a bit more about that?
It's kind of a hard, so it's kind of a hard thing to demo, because I will hopefully not be running out of memory when I show you things.
I'd just like to see what it looks like.
Oh, okay. Let's start off. Any other questions? Sorry, I didn't see anyone else. We'll go on to examples. Okay, so also I'm not claiming this is idiomatic Clojure code that you should copy, right? It's kind of coming back to these code bases. These are all real things that I've written to solve real problems. And looking back at them and kind of go, oh, God, it kind of reveals something about you, doesn't it, your code? Where do we want to start? Sorry, the resolution of the monitor makes my screen really tiny. Okay, so a couple of years ago, so The Guardian has a film database with lots of interesting information about movies, who appeared in it, and what genres it's in. And it was in an Oracle database. And I'd love to run this code, but a couple of months ago, I told the data team that we would never need this data again and they should put it in deep storage. And a couple of months later, I go, oh, fuck, I should show the film code. And I can't because I didn't save a copy of the data. So I'll have to rewrite this at some point. So I have the read credentials to an Oracle database. There is interesting information in that Oracle database, but no one else can access it unless I share the Oracle credentials with them. Okay, so what I want to do is I want to take the data and I want to present it in a new format that is more consumable, which is namely JSON. So this code uses a library that I like a lot, which is called SQL. And the thing I like about it is that it does this. It puts SQL in your code. So all these queries are just things that I've run in SQL Developer, or other SQL runners are available. SQL Developer. I've run it, I've checked it, then I parameterize it with bind variables because it's Oracle, and then I put it in here and I replace the bind variables with question marks to make them SQL parameters. Each one is named with a short description, and so these are just all the queries that you could run on that database that were interesting. And then this is my whole web API. So this is based on a library called Clojure. And let's take it from the top because it's less than 50 lines, right? So it's not going to be complicated. So we have a bunch of import stuff about what I'm using. If you've done any Java, this section, this is pretty self-explanatory. These are the connection details. I'm just pulling, because we open source loads of our code bases, the way that I keep private information private is to just put it in environment variables, and then I can release the code, and I know what the environment variables are in my shell, and you can look at the example, and that's all fine. I don't think it needs to be more complicated than that. It is more complicated than that, but when you deploy to AWS, but let's pretend we're not doing that anymore. So then we have a couple of functions which generate the queries. Okay, here's an example of what you shouldn't do. This def queries on 17. This is a terrible insight into what I am as a programmer, which is really lazy. So def queries is a magical macro, and it will take that SQL file that you saw, parse the comments, and generate a Clojure function that wraps the SQL statement by the name that I gave it in the comment, which is really awesome. And it puts those functions in your namespace. That's all amazing, except it magically makes loads of functions appear, and that's fine because I know what I'm doing. But in terms of maintainability, you want to use a different form, which is require SQL, where you give them explicit names, you give them a namespace. So don't copy me here. But all these things filmed by PK are, back to my time screen. Filmed by PK is just literally the name there. It's generated a reflective magical function for me. So I'm going to take the movie data. So for some, in films, apparently actors are not actors, they are players. So I pull back the actors who appeared in the film and the genre tags that are associated with it. And that final line, that ad-hoc, just builds a map, right, a Clojure map. So this is all kind of native Clojure, and apart from the queries, I could pass in an ID and check that it gives me a map. So I could abstract some of this data and make it testable, but I'm really lazy, right? I didn't do that. And so the def roots part is where the URLs appear. So they're just really simple. You put movie, you put an ID, and you've got to know the ID. For domain reasons, you will know the ID. So I don't need to put a discovery mechanism in. And that map will automatically get munged into JSON by this line right at the bottom, which is a piece of Clojure middleware that will just take a Clojure structure and generate the naive JSON for it, which is fine, and that works. So that was about half a day's work. It's a very small code base, and it took data that was locked away and inaccessible and opened it up for other people to use, right? That's just like I think that's the kind of first example where I thought this was really amazing. You know, a small amount of effort made data more usable in my organization. That's my first example. Any questions about that? No? Great. I'm going to assume that's good. So let me bring up the other thing. So the question that kind of was the impetus for the talk was someone came to my desk and said they were building a page pressing system for a site. So we have old content on The Guardian that essentially there isn't editorial agreement as to how that content should be presented in future, and there are tens of thousands of these pieces of content. So it's not trivial to get an editorial decision on each one about whether it should still be presented, whether it should be presented in a different way. You know, we've changed designs twice since this content was written. It's a miracle it's still going. And so with those things, what we do is we page press them, we freeze a copy of them, and we'll serve it as is until someone makes a decision about how it should be presented in future. And so someone said, like, can you just tell me which URLs I need to press, right? So they're responsible for building a page presser. It's a classic kind of lazy cross-departmental responsibility. Like, can you just tell me what to do? And I was like, I'm not, okay, I guess I can, because I have access to the database, so I know all the instances of the content that were ever published. The difficulty I have, and the reason the person's asking me for just give me the fucking URLs and I'll do the other side of it, is that there are various rules that explain whether content, so once content's been published, it's always considered live, and it never changes in the old CMS data store. But there are a bunch of other domain rules that apply. So, for example, if you use a piece of poetry that someone's given you rights to use, quite often those rights are time limited. So if you use a piece of poetry, that piece of poetry will only have rights of a year, and after a year, the system will automatically expire it. But because that stuff got published, you don't delete it from the live content table. There's a bunch of other rules that say whether something is actually live or not. And it's really complicated to do in Oracle because it's a really complex set of relational queries. But it is very simple to do because we have an open platform. We have the Content API, which is an amazing thing, which is all our content is available on the Content API if you have the right API keys. So if I can get from the ID to the content platform representation of data, then I can look at its publication status and say whether that content is live or not. And even better, they will give me the public URL, which is what the person who's doing the page pressing needs. So I wrote that code. So the first thing I needed to do was generate all the IDs of the content types that I wanted. So these are the four kind of obsolete content types. And originally I was thinking, I have to connect to the database. Just as the previous example with the film, I need to write some queries that will pull this data back. And then I realized that we weren't publishing any, these were obsolete, so we're not publishing any new types of them. So actually the data set is fixed. So I only need to run one query, and then I can do this genius thing of just putting a list of the IDs right in the code. And this is a data structure of a list, and that's all I need to do. I need to take the results, turn it into a list, and I'm done, because I never need to go back to the origin system to sync. So I just created a file called data, which is all the data, which is what I would have done if I got the queries. No. So let's try. Which one did we? Does anyone have a preference for what we try and do? Let's try polls. So what I do is I create a cache because initially I didn't have a cache, and I got all kinds of weird failures where I was like over quota on my use of the API because I wasn't using the right key. So I'd got half the data, and half the data was like access denied, and I went, shit, I've got half the data, and what I'd really like to do is fill in the other half of the data, but like I ran it once. So the cache basically was just it's a thing in Clojure called an atom. How many people are familiar with Clojure here, by the way? I should have asked this at the start. Okay, 50-50. So an atom is an atomic, you can effectively think of it as an atomic reference from Java. Is everyone okay with atomic references in Java? No one's prepared to admit they don't know, so that's fine. So it's an atomic reference around a map, and that is my cache. And then I need to... Another lazy thing I don't do is write proper documentation for my functions. And at moments when you've got like 50 people staring at you, you go like, oh, I should have done that. but most of the time I can remember what they are. So pass it the cache to populate. I'm going to take a guess. So I need to say where the content API is for me, and I need to say what my key is. So let's say polls. And so polls is just the symbol into that table in the code before. So it basically says use that list of IDs. Okay. And so let's just assume that's running and it's all going to be successful. And we'll go back to the code. So what that is doing at the moment is going through that list of IDs. It's going to the content API and using an internal layer to say, I have this internal code. Can you tell me the related information to that code? Okay, so how many lines is this? It's about 50. Clearly, like whenever a code base gets to about 50 lines, I get bored and stop writing it. So it's about 50 lines again. So this is the first bit, which is just poking in the host and building the parameters. And so this is going off to the content API and saying, do you know about this piece of content? And I was trying to be clever. I'm using an asynchronous HTTP library, right? Because async is fast and performant. And then I realized that I can't do the next stage of the processing until I've checked all the content IDs, because the questions I have are all about aggregates, like how many of these things are published. So there's no point having all the intermediate stuff. So that's a complete waste of time. Sometimes you need to do things in serial. Is there anything interesting? Oh yeah, there is an interesting bit. So why do I print it out here? I clearly had a problem at this point in the code, and I print something out which I never use. So this thing about being an app promise, it's because that async code, I need to wait for it to finish operating. And then the body that comes back is obviously a HTTP string, and I need to coerce it into JSON. So I'm using a JSON parse library here. So I'm just saying, get that body and stick it in and ignore errors. Yeah, it's good. It's like if it's boring, you should just leave. Okay, generate a URL. So given the IDs, this is totally uninteresting actually. So given that data structure of IDs, you just want to generate all the URLs and look them up. Clearly cache ID 1 didn't work, but I wanted to refer to it later. But cache ID is the correct function. God, this is awful. This is what real code looks like, right? Okay, so now we're at the point where we're at the external interface that we're actually seeing, right? So originally I had a map over, take all the IDs and look them up. And the do run is the thing that kind of forces the evaluation, because I realize there's no point using it. We were talking about laziness, right? If I didn't have do run, the map would be lazy and immediately complete with no results. And then obviously I would ask a question like, how many are there? And go, oh, you're interested in the content of this. So now I will go off and make all those HTTP calls to answer them for you. So I was like, the first time I ran it, I was like, God, that's really quick. Async's amazing. And then I asked a question and sat there for 5 minutes while it calculated it for me. So that's the kind of, in this case, it was doing something that deferred the execution of the I/O until I needed it. But my domain problem required me that I need to eagerly eval it. But if I had a slightly different question, which is, give me the first 20, sample this data, then if I had, I might have 10,000 polls to look at, but I might just be interested in the first 10 to have a look at. In fact, hopefully when it's stopped executing, we'll go and have a look at that. And in that case, I would have got value out of laziness. And then these are some functions that the error responses, OK responses are just saying like how many of these are there. They are just formulating questions that I was commonly asking. And you can see my interest decreasing in this because it started working. I'm not codifying the code anymore into proper functions. So at the point, this double colon thing is a comment, which is clearly just something I've done. And I thought was interesting, and I haven't been bothered to turn it into a proper function. I've just put it in a comment because I intend to cut and paste it back into the REPL. So clearly I was solving my problem at that point and losing interest rapidly in this code base. Sorry?
So I'm kind of sold on this approach for ad-hoc queries, which happen a lot.
Yeah. So I guess the data wrangling side of it is the ad hoc nature. When you need to productionize something, I think you need to take a different approach. The most common thing I find is that people have an intense interest in something for a period of time. So quite a few things I've done at The Guardian have been intense periods of work that limited. So we used to, one of the worst things was being involved in the domain change. So we changed from www.guardian.co.uk to www.theguardian.com. And that was a massive amount of work because quite reasonably, everyone who had ever worked on the code base before had gone, no one changes domain. That's crazy. You'll never change domain. And so effectively you unpick 8 years of hard-coded decisions. But I didn't approach that problem like, we'll probably change domain again in another couple of years' time. It was kind of like, I'm going to do a one-time fix to this, and then this code will go away. And so most of these code bases that I have, they are deliberately one and done. And I'm not trying to present them as how you would do things in production. Yeah. Enterprise analysis. Nice. I think the ironic truth about enterprise analysis is that it's less systematic than this. I think people pull things like, I want to pull a day's worth of data and put it in my Excel spreadsheet, and then I'll run my formulas on it. I think a lot of businesses really have that, and I've seen how that can go hideously wrong. We started in the UK, and we now have offices in Australia and New York. And the number of times that people go like, I need a day's worth of data, and you go, for Australia, the US, or the UK, or do you want UTC dates, which are very abstract? Oh, yeah, sorry. Yeah. Yeah. There are, because I'm not involved, this is more of an experience report, I'm not involved in that. You can absolutely use these tools to do sensible data processing that is repeatable, reconcilable, and responsible. But I am not the person to talk about any of those three things. I've got some, let's see. Because I don't have any slides and I'm just showing you the code, I've published a blog post this morning. My blog is Rees, and it's the first post today. And it has a lot of links to libraries and people who I think do a really great job. And two of the people I would recommend looking up after this, if you're interested in serious, proper data processing and not the ad hoc stuff that I do at the behest of my colleagues, then Bruce Sterling and Henry Garner have done really good talks about statistical analysis for things like Encanter. Henry's done a great talk about parallel processing of data that is in the gigs, not big data. Henry's also has done a book about using Clojure with stuff like Hadoop clusters for much bigger scale data. And I've got links to talks about some of the libraries like transducers that allow you to do multiple operations over things like 30 cores. Like I have 4 cores. Which if you're a node developer, is like, why do you have all those cores? But if you're a big, serious enterprise, you've got a box with 20 cores, you want to put parallel jobs across all of them. Okay. We have 5 minutes left. Okay, so we populated, I'll just show you this is a real thing. Okay, we've got 5,000 pieces of data. Okay, this is the first entry. The number, the first number. Think of your last minute questions while I do this. In all honesty, like, people are surprised, and like when I give them the answer, they just shut up about it. Okay, so the first entry is the ID, and the second is response. So I can go into the second and say, show me the JSON for this piece of data. It's a bit of a flip answer, but it's not my job. It's the weird thing. It's like I am trying to achieve something else. Like, I want to migrate the Guardian site to use HTTPS because I think it's a good thing. If people can't answer, if I can answer their questions more effectively by using technology to solve it, then I will. But we have a whole data science team and data analysts, and they could also answer these questions. But I guess stuff like the API is maybe my way of trying to offer some kind of long-term thing, saying, okay, I'm going to give you the basic tools, but I'm not going to solve your problem every time. Yeah, so here, this is the JSON result. So we had a poll about Obama, and that's a live one, so it would be 404 or 410 if it was not live. So maybe I can find the status request just to prove. Oh, sorry. Let's look at the headers. That's not right. Oh, they're boring. So I did this last night in the hotel, and it had all my guest Wi-Fi credentials added in the headers. I thought that was really fun. I guess it's all that hippie shit about connected Bristol, right? It's like free internet with no tracking for everyone. Yeah, so it's got a status code of 200. Okay. Mm. So I think the issue is that people aren't prepared to solve their own problem under any circumstance if they're asking me to solve it. So I will, like I did, there was actually a request the other day. It's like, oh, can you tell us how to do this? And I'm like, yes, I will tell you how to do it. in the way that I am doing it most conveniently for me. And if that leads someone to get an interest in Clojure, that's great. But if a lot of times things that I've written in Python on Clojure and just done, I do have colleagues who spend weeks rewriting it in Scala, and it's like, fine, if that's what you want to do. I don't think it's any better. I think you wasted a lot of time doing it, and we got the same results. But the working in a kind of digital autonomous organization is that people can make bad decisions, right? You can only guide them. I am going to get thrown off. So I'd like to thank the Guardian for helping send me here, for the organisers for asking me to talk, and for you for listening and asking great questions. Sorry. Thank you very much.